Hi, this is Ryan, and I'm going to show you how to do the basics of Openscad. Openscad is an open source parametric CAD program. This program lets you create 3D models in a very simple programming language. You should see an example on the page right here. Everything you see on the left side that I just highlighted defines what you see here. And it's a fairly simple language. I mean, you can read and kind of see what it does. I'm going to open up a couple examples just to show you. That's just example 1 and F5, and you'll get a new example. And it's, again, simple, easy, pretty beautiful. But yeah, Openscad programming language. I'm going to show you a quick little demonstration on how we get from an idea to a product, kind of. I'm going to just do something simple for first. It should be just 3 or 4 objects, and that will generate the model and file that we need. I'm going to try to make these useful things that I might need or you might need. If you have any requests, just send me an email or a comment. And here, we'll start a new file and get going. So what I'm going to do is I'm going to show you how to make a T-slot nut. It's used for like clamping and holding things. It actually, there's a groove. Here, let me see if I can pull one up real quick. T-slot. It's used a lot in 80/20, probably in OpenRail. Images T-slot. So like this. So you have a nut that goes into this slot right here. And that nut usually has something like that in it, and you have a lever that you bolt down onto the object that you're needing to secure, and it holds it to the bed without damaging the bed, the object you're clamping, or the clamp. It's really neat. I'm going to show you how to do a quick little SCAD of one. Again, it'll only take like 3 or 4 objects and we'll be done. We're going to start with a cube. I'm starting with fairly random numbers. They're small, easy round numbers. Makes everything really, really easy just to prototype out, and then you can expand those numbers to whatever you actually need. So what we're going to do is generate a cube. And to do a cube, you do cube, parentheses, square bracket. And we're just going to do, I'm going to have the X be the front, the Y be the distance going away from us. So 4 by 8 by, let's do 2. Let's see how that looks. And just to finish this out, make sure you have your semicolon, and there is our cube. It's really a rectangular 3D object. Trying to think of the word for that, but I can't. But yeah, so this is our base. It looks pretty good. It doesn't look like we're going to have to do any adjustments. So I'm going to make the next part of this object, which is going to be another cube. And we're going to take our definitions for that cube from this one. What should I do? I think I'm going to do something kind of silly. I'm going to have this cube go on top of this cube. So I'm going to put in a translate, parenthesis, square bracket, not curly bracket. And we're going to do 0, 0, 0 as just placeholders right now. And I'm going to do the cube as, let's actually bring this up to 6, 10, 4. And yep, that's what happens. I'm just going to comment this out real quick, and I don't like how that is, so I'm going to bring this down to 3. Let's go back to 2. See? Nah, that's too small. 2.5. That looks about right. We're going to bring this back in. To comment out, you just put // and it comments it out, and it doesn't get compiled and is ignored. Kind of useful if you're just trying to do some experimentation to see how everything works. So we're actually going to have 0, 0, 2.5. We know that's going to be the height. Let's do the width as half. And this is going to have to be translated up by the height of the object. And then the length is going to be the same as the other thing, the other length of the other cube. So we're going to hit F5, and it's not going to get compiled because I forgot that semicolon. So right now we have some like L-shaped object. That means we're going to have to translate it. It looks like we're going to have to translate it half the width. So it looks like it's going to be translated in the X by 1.5. That looks pretty good. Again, I don't like how skinny that is. I'm going to make... Let's make this 8. This 4. And then we can probably make this 2. There we go. That looks a little bit more solid. It's good to make it look right, you know? And again, you can change all these numbers kind of on the fly. We could probably make these variables within the program so that they're very easy to change. I just haven't done that yet. I could do a short video if it's needed or requested to do that. It's easy. We just replace the 2.5 with like an A, the Y with a B, and then 8 would be an X, so you do X divided by 2 and you get the 4, and then X divided by 4 would get the translation for the X. But yeah, I'm gonna do that maybe later. It's not really needed now. You can just think real quickly and kind of get it prototyped out as it is, and then, you know, modify it as you need it later. Right now, I'm going to turn this into union, so this is a single object. It makes it easier to work with. No worrying about taking it and doing multiple operations to the same thing, because you're going to modify this entire object anyway. You're going to want to drill a hole, which we're going to use the cylinder command for that. So yeah, you don't really want to muck around with it too much. So the union just causes you to save a difference or two. And then we're going to add a difference. Another curly bracket. I'm going to do this just to make it easier to know what we're modifying and which goes what goes to what. So we're going to the first object, the union, is what we're modifying, and what we put below that is what we're going to be doing to it. So we're going to do a translate on the cylinder, and again we're just going to put some placeholders. 0, 0, 0, so it goes into the natural spawn point for the object. And I'm going to do cylinder R is equal to half of 3. I want it to be smaller than that little extra point. So half of 3. Is that right? Yeah, that's right. I wonder if I could set a diameter. I don't know. I haven't seen a command for that. And I want the height to be 5, so that it goes all the way through. And we're just going to put a semicolon. I always forget the semicolon, so it's always good to remember to kind of say that to yourself, double check. And we're going to generate, and what happens? It disappears. Because I believe difference is not the right, I misspelled difference, I'm assuming. And there we go. Just a minor misspelling. Oh well. So right now we're going to translate that to the middle. And we're going to translate that back a bit. I'm going to go to 5. And that should get an object right in the middle. As you see, it generates a really chunky cylinder, a pentagram right now. What we can do is we can add number of polygons, upgrade it, I guess. So right now it's at 5. We could be silly and bring it down to 3. We can go up to 6. Brings it up to a hex. Septagon, I believe. Octagon. And let's see, is an octagon round enough? Let's bring it up to 10. A decagon. And that actually looks fairly round. Well, the application I can see for making something like this is to 3D print it. And you don't actually need that fine of a detail for a round. It's actually better for your G-code generation if you have a kind of low-grade circle. It generates quicker. You make better moves, so your nozzle isn't doing a bunch of little tiny jaggies. It's doing longer movements. So yeah, that circle at a kind of lower resolution helps a bit with G-code generation. And that is a simple T-slot nut. What I'm going to do though is I'm going to take that cylinder and I'm actually going to punch a hexagon into the bottom using the function, I don't know what that's actually termed as. Let me find out. Fn resolution, so it's just called resolution. I don't mess with the $FS or $FA. I could maybe generate a better object. I could mess around with that. I just haven't. The $FN has worked perfectly fine for me, and it's kind of fun to tune it. I like seeing the different iterations. So what that'll do is a difference. Now I'm trying to debate if I want to do a another difference or a union in this difference. I think I'm just going to add another difference just to show another stack on here. So yeah, I'm just going to move all these out. Makes it easier to tell what you're doing. Cleaner. And difference, parenthesis, bring that down, come down here, and we're going to do a translate, and we can actually just copy that translate, and it should be fairly easy. Just the 4, 5, 0, and we're going to do a cylinder R. Let's see. I don't have any direct dimensions of what would that create? That'd be an M6. No, that wouldn't be an M6. That'd be an M3. An M3 bolt head. I could probably pull that up on the internet, but again, we're just doing a quick little demonstration. And with just a little bit of tweaking, we could easily get that going. Get it close enough, at least. That's all you really need. You can just glue it on, and you wouldn't have to worry about it spinning anyway. But we're going to do cylinder R equals, let's do 3. That's going to be fairly large. Let's do 2. H is going to be, let's do half the height of the first block set. Height is that, and then the resolution is going to be 6. As I was saying earlier, it's going to be a hexagon. right? Yeah, hexagon. And we're going to put a semicolon. Don't forget the semicolon, because you will, and you'll wonder why your thing didn't get generated. We're going to hit F6, and that just leaves a nice little bolt head type thing right there. So what you're going to do is thread a bolt through there, swap it around, and use that. I use like a device I could draw up fairly quickly, and bolt that onto your object and cut it. What I would actually use this for is I'm with a hackerspace called Arch Reactor, and we've got a new CNC machine that we are just finishing up. And I think we're going to get T-slots in the bed. If not, I'm going to make a couple of these and make a suggestion, and hopefully they get moved through. But I would happily use that to make some clamps and stuff to hold down the material as it's being cut, so it won't move, and we'll get a nice cheap method of holding it down. Alright, so that's actually fairly done. If you have any questions, just ask them. You can find me pretty much anywhere with BASLISKS. Again, BASLISKS at Gmail. You can make comments on my YouTube channel. I'm on it fairly frequently. And this should be good. Thanks. Have a good night.